Hello again. In this video, we have this example. I have a positive 12 microcoulomb charge is placed at the origin. At a second charge, negative 8 microcoulomb, placed 1 meter to the right of the first charge. A third positive 6 microcoulomb charge is placed 1 meter above the charge in the origin. What is the net electric field at point or at coordinate 1, 1 meter? So we can say this is our Q1, which is positive 12 microcoulomb. That's 1 meter to the right. It will be Q2. It's a negative 8 microcoulomb. And I have Q3, which is the positive 6 microcoulomb above the origin one by 1 meter. Now this is the point B, will be here, the coordinate 1, 1 meter. So I know the distance between Q3 and point B will be 1 meter, and the distance between point B and Q2 will be also 1 meter. And by calculating the distance between Q1 and point B, it will be square root of 2. Let's start calculating the electric field 1. And it is K Q1 over R1 square. And that will be 8.9 10 to the power 9 multiplied by 12 10 to the power minus 6, all divided on the distance square. That should give me 53,400 Newton per coulomb. Now to decide the direction or identify the direction of the electric field 1, it will be, we have a positive charge Q1, and the electric field at point P will be away from it. So this is the direction of E1. Let's calculate E, the electric field generated by the second charge. We're following the same formula above, and it will be 8.9 10 to the power 9 multiplied by 8 10 to the power minus 6, all divided by 1 square. And that should give me 71,200 Newton per coulomb. And to identify the direction of the electric field, well, Q2, as we can see, it's a negative. So the electric field at point B will be going in or toward the direction of Q2. So that will be our electric field 2. Which means I can place a negative value here to represent the direction to the negative y axis. Okay. Now let's calculate the electric field generated by the third charge. And it will be 8.9 10 to the power 9 multiplied by 6 10 to the power minus 6, and all over the distance squared, and that should give me 53,400 Newton per coulomb. And to identify the direction of the electric field generated by Q3, it's a positive charge, which means it's going to be going away from it at point B. That will be our electric field 3. Okay, so now we managed to calculate the magnitude for every single electric field generated by every single charge at point P. Now to calculate the net electric field, we still need to do one more step, which is analyzing the electric field 1 into two components. And we have the angle here, it will be 45 degrees. Okay, so what I can do, I can redraw the whole thing, and this is my point B. That's my electric field 3. That is my electric field 1. And this one will be my electric field 2. Now I can, this is the angle we set, so 45 degrees, which means I can analyze the electric field 1 into two components. One will be electric field 1x, and also electric field 1y component. And I can do the math for each one of these components. I say E1x, it will be the magnitude of E1, or the electric field 1, cosine 45 degrees, and that should give me 37.75 10 to the power 3 Newton per coulomb. For the y component of the first electric field, I will have E1 sine 45 degrees. It will be the same sorry, it will be the same value as the magnitude, and 7.5 10 to the power 3 Newton per coulomb. So all right, now let's find out how much is the total electric field on the x-axis. So the total Ex will be, I'm adding all the electric field vectors on the x-axis, so I will have all these together, E1x plus E3, and just doing the math for that, it should give me 91.15 10 to the power 3 Newton per coulomb, and it's definitely going to the positive x-axis. For the total electric field on the y side, or y-axis, I only have E1 y component plus the second electric field, and if I do the math, that will give me a negative 33.45 10 to the power 3 Newton per coulomb, and the negative helped me to say it is going to be going to the negative y-axis. So to find the net electric field, I only need the total electric field at the x direction and the total electric field at the y direction, and that will give me E net equal Ex square plus Ey square all under square root, and you just need to multiply the total x, or sorry, you're gonna do the squared for the x and the total x, and the squared for the total y, and that should give us the end 97 10 to the power 3 Newton per coulomb. That will be the net electric field acting because of the three charges at that point P with these conditions. Obviously, you can also add to this question finding the direction of the net electric field. That could happen or could be asked, but we leave it maybe for another example in a different video. I hope you find this example useful, and I will see you in another video later on. Thank you.